So on this first problem, it says graph the function x to the third minus 2. I think most of you are probably going to go straight to your graphing calculator and just go y equals, I would think. The most important part about this is like when you're looking at your window of your calculator, you want to make sure you've got like -10 to +10 on your mins and maxes. And when you go to y equals, you would type in x and then rooftop 3 minus 2. You either want to, when you do that, you either want to, when you look at your graph, you either want to make sure you kind of know where a point is so you can kind of have a reference. So I like to always look at my y-axis here and go, okay, this graph is going through the point 0, -2. And I want to eyeball that so that I know when I go back to my paper that it has to go through that point 0, -2. But it basically looks like our graph just been shifted down to. Yeah, B, right? So that's the one. Let me blow this up just a little bit. Oh, I can't. Let me do that. Okay, so if I, yeah, it looks like it's B, the one that's been shifted down to. I mean, this one, 0, -2 would be over here. So it's not passing through it. This is 0, -2. Here's 0, -2. That one's not even going through it. This is 0, -2. So that point kind of helped me if I was having trouble reading my graph, make sure I got that part correct. Number 2 is asking you to plug in -2 wherever you see an X. So that if they want you to do f of -2, you would basically leave all of your X's blank. I like to put parentheses there because it helps me from, it keeps me from making mistakes when I type it in my calculator. But 3 times -2 squared plus 5 times -2 plus 3 is going to give you 5 when you plug that in your calculator. Okay, everybody good with that? I don't mind going to the calculator and doing that, but if you type it in just like that, that's what you should get. What do we want to do to determine if a graph is a function? If you're given the graph, you want to do the vertical line test. And you remember that when you draw your vertical line through your graph, it doesn't matter where you draw it, but anywhere on the graph, if you draw this vertical line, I don't know why I went over, sorry, it can only hit it one time. So if I drew it right here, it would hit it right there, but this is a function because it's only hitting it one time. Right? And only hit the graph one time when you draw a vertical line. Okay. Solve this system of equations. So we just got through talking about matrices again, and that's what I think the majority of you are going to do on this one. And so you would make sure your X, your Y, and your Z's lined up, and then you have your answer over here or your equals lined up. So we have 1x, -1y, 4z is equal to -12. On the next row, we have 4 x's. We don't have any y's here, so it'd be 0 y's. 1z is equal to -2. 1x plus 3 y's plus 1z, I'm just getting this information right here, is equal to 10. Is everybody okay with that? Like where I came up with that stuff? Okay. This is where you would want to go to your graphing calculator and go to second matrix. And I'm recording this as well, so I'll post this if you need to go back and fast forward to whatever you're looking, the problem you're looking for. But you can hit enter, and then this one would be a 3x4. And you would type in what we just did. So 1, -1, 4. Okay, so after you type in your matrix, and I'll go back and write a few things down on the next page, but what the step would be, get out of it. And then you go second matrix, go over to math, and you want to find that thing, RREF, enter. Second matrix, enter. Close off your parentheses and hit enter. And you're going to get this, and this last row is your answer, the 0, 4, and the -2, right? And it's been a while since we've worked one of these. So when we go back, we had to do RREF, matrix A. We hit enter, we got this stuff. And your answers were on this last row, and that's why the answer is C. When we're talking about the domain of a function, we're talking about what can X be. And so you want to kind of look at your limits on your X axis. So it looks like when you're going from left to right, it doesn't look like there's anything on the graph past this to the left, and to the right, it looks like it's kind of bordered right here. So it's all this stuff kind of in between those two. There is a dot that is filled in at -4, and there is a dot that's filled in at 4. So it would be B, and there would be a brackets because it's allowed to be -4 and +4 because it's filled in there, but it's all the stuff in between -4 and 4. To be able to work number 6, you're going to need to, I think the majority of you are going to want to plug what the line looks like in your calculator. And we went over this before. This is not the only way to do this, but most of you said I would just go ahead and solve it for Y so I could type it in my calculator. That's what kind of the method that we decided we would go with. So to solve it for Y, you want to remember, like, if you have to, just make yourself a note. If you multiply or divide by a negative number, you want to switch the sign. So if it's less than, make it greater than. If it's greater than, make it less than, right? When you're solving these. But we would subtract 4x. I'm just trying to get Y by itself. So -3y is greater than or equal to -4 minus 4x. You would want to divide by -3, and you want to divide everything by -3. I divided by a negative, so these are going to cancel out, but that's going to end up being less than or equal to +4/3 because it's negative divided by a negative. Another +4/3 times x when I separate those things out. I'm sorry, what? If I said make it equal to 0, I messed up. I'm just trying to solve it for Y right now. And I think you're a step ahead of me, because in a minute we're going to do a test point to see which part we need to shade in, right? At this point, I'm just going to go to my graphing calculator. And I'm gonna say, well, I need to figure out what this line looks like. So I could just go here and say, well, go to y equals and just type in that line. So 4/3, not 6, sorry, plus okay, and I could just graph it. So I know the lines at least got to be going up. I mean, if you look at your graphs, the only line that even goes up is D. The rest of them are going down. Do y'all agree? Okay, so I know already it has to be D, but if I didn't, and there was one that I needed to do, what I would need to do is pick a test point. And we really like to use the point 0, 0. So X is 0 and Y is 0 to figure out what part of the graph we shade in. So what we're trying to do is use our equation that we started out with, our inequality that we started out with, and plug in 0 here. Plug in your test point and see if it's true or false, right? See if 0, 0 is supposed to be shaded in or not. Well, 4 times 0 minus 3 times 0 is 0. And you ask yourself, is 0 greater than or equal to -4? The answer is yes, it is. So 0, 0 should be shaded because the answer is yes. So on this graph, it is 0, 0 would be, it's hard to do this because this is also colored in black, but it would be about right here. On this one, 0, 0 would be right here. It's not shaded in. So far this one would be okay. This one is not shaded in. So this is a no. So no, because 0, 0 is not shaded in on either one of this. And then this one, 0, 0 is going to be shaded in. So this one would be okay. But we know the right answer is D because the line had to be going up. This line's going down, right? So if we combine the two things on this one, honestly, you don't need to figure that out because the only line that was right was D. But I don't know if it's going to be that easy on the test. So you would pick a test point, figure out which ones, if the equation is true or false, and figure out which part you should shade in from that. Does that make sense? It's been a while since we talked about that one. Okay. So here's one of our favorite problems because it's a word problem. I'm joking. But the beauty of this is the word problem should look exactly like this one. It just should be numbers changed. So it should be a ladder and it should be resting against the wall. And the top of the ladder touches the wall at a height of 18 feet. So it should model this exact thing. As long as you know how to do this problem, you should be good. It says find the length of the ladder if the length is 6 feet more than its distance from the wall. So I'm going to say the distance from the wall is X and the length of the ladder is X plus 6. And so this is one of those problems that you had to use the Pythagorean theorem on. You had to say the legs squared, when you add the legs squared, it's equal to the hypotenuse squared. So you would say, well, X squared plus 18 squared. The legs are always the parts that are connected to the right angle. And then the hypotenuse is always the one across from the right angle. And that has to be over here by itself. So X squared plus 18 squared. $18 squared is 324. And then this is where a lot of people are going to mess up on this one. They'll say X plus 6 squared is X squared plus 36. And it's not. It's X plus 6 times X plus 6. And that's not X squared plus 36. You need to actually multiply that, FOIL it out. So X squared, that's the first. Outer would be 6X. Inner would be 6X. Last would be 36. So X squared plus 324 equals X squared plus 12X plus 36. Is everybody okay so far? I just kind of simplified that FOIL. This one was one of the nicer ones because we know it's quadratic at this point. But when we start solving it, we would try to get it equal to 0. So we would subtract an x squared, and those end up just going away. So now I just have 324 is equal to 12x plus 36. Subtract 36. Not add, sorry, subtract 36. 288 is equal to 12x. Divide by 12. So x is 24. I'm going to say this is multiple choice. So here's the tricky part. Make sure you answer the question, because it's not asking you x, it's asking you x plus 6. It's asking you how long the ladder is. And I heard somebody say that. You're exactly right. You need to do 24 plus 6, and you need to get 30. Make sure you answer the question. Make yourself a big note on that one. On number 8, we know that there's a problem in the domain when x squared minus 9 is equal to 0. You can use your poly root finder to do this if you want to, but this one, just using algebra, it makes this problem is pretty easy to solve just by using algebra. As you would just, but your calculator will tell you this answer if you use your apps, but plus or minus 3. So that's where I have problems at positive and negative 3. So it would be A. There's a problem at it's split at negative 3, and then it's split again at 3. There's something wrong in the domain, because that's going to make my denominator be 0. Okay, is everybody good? Okay. Number 9. Also a problem that gave some of us fits, but we talked about just taking this in steps. So we're trying to solve this. So if you go and look at the back end first, so do this, I'm just gonna put a 1 down here. So do this put your little fraction, and then put your minus sign and check that off. And then do f of x. Well, we know what f of x is. F of x is all this stuff, right? It told us f of x is 6x squared plus 2x. We know what h is on the bottom of the fraction. So we could take care of those things first. Then we can come back and deal with this whole, like, what is this f of x plus h? And I'm going to come down here and write it. F of x plus h. Is everybody okay so far? So all they're asking me to do is wherever I see an x, so 6 times, I put a big blank there, plus 2 times big blank. Wherever I see an x, I'm supposed to put in x plus h in that blank. That's the only thing we've changed. If this is f of x plus h, wherever we see an x, we're going to put a big blank, and we're going to put x plus h in that big blank. And that's what goes right here in the front. So 6 times x plus h squared plus 2 times x plus h. When we were going over this in class, we even figured out what x plus h squared was. And we wrote down that it was x squared plus 2xh plus h squared, so that when the time came, we would have that. We wouldn't have to multiply it out. Okay, anybody lost so far before we start simplifying this thing? Okay, so I've got 6. X plus h squared is this stuff right here. So I'm gonna say 6 times x squared plus 2xh plus h squared. So that took care of that first thing. I'm gonna go ahead and multiply the 2 out here. So plus 2x plus 2h. I'm gonna go ahead and distribute this negative to both of these things. So minus 6x squared, sorry, minus 2x all over h. The only thing left, and some of you probably could have went ahead and multiplied this out in your last step instead of making a whole bunch of extra steps. But I need to multiply that 6 by everything here. So 6x squared plus 12xh plus 6h squared. Then I'm just writing the rest of the problem out. All over h. And remember that everything should go away unless it has a h in it. So at this point, some 6x squared minus 6x squared, 2x minus 2x, and everything else that's left should have an h in it. And I like to split them up so that it's easier to see how the h cancels out. Because this is going to go away. One of these h's takes away one of these, so I still have one. And this h takes away this h, so you've got 12x plus 6h plus 2. And you can see that there's a lot of tricky answers that are pretty close to that, right? Remember that you could kind of spot check where you were by taking this original function. This was kind of a cheat. If you've got 6x squared plus 2x, you would take the 2 and multiply it by the 6. So that would be 12. And then you would subtract 1 from your exponent. So it should be just 12x because it's x to the first, right? This is a 1 here. So you would do 1 times 2, which is just 2. And if we subtract 1 from this exponent, we wouldn't have any left. But you got to be careful here because that answer is here, 12x plus 2. This is just a way to spot check yourself, but it leaves out the h part of it. If you do this, it leaves out the h. So you should be able to kind of know, oh, there's only one that looks like that has h, so that's it. But again, you don't have to do any of that trick stuff, but it does kind of help you see if you're on the right track, if you got the right answer, okay? Number 10, negative 2 times the square root of x. Let me stop real quick. So you may have questions or I need to slow down. Okay, so graph the function f of x is equal to negative 2 times the square root of x. This one is pretty easy to do on your graphing calculator. Just mess with that. So y equals negative 2. Square root would be second x squared x. Look at the graph. There's only one that really looks like it there. Which one do you guys think? Yeah, it has to be C. That's the only one that even looks close to it. So that one's not bad at all. Yeah. So far, let's work number 11 and then we're gonna quit for today. Because Thursday we have plenty of time to do 12 through 25, but this says determine the intervals on which the function is increasing, decreasing, and constant. So increasing, remember that you always want to go from left to right, and this has to do with x. Okay, so you're always comparing everything to the x-axis. So you want to start here on the left. So when you start on the left, it looks like the first thing that's happened is it's going down. It's going down till about, I'm going to try to draw a straight line, but no promises here. Okay, so it looks like about negative 4. So x is negative infinity here. So it looks like it's going down first. So it would be this would be decreasing from negative infinity to -4. Then it kind of levels out. I'm looking at the answer, so it looks like they're saying this is 4. So it would be constant from -4 to +4, and then this is where you end up at. It's going up again, so it's increasing on the interval from 4 to infinity. Okay, so C, increasing from 4 to infinity, decreasing from negative infinity to -4. So negative infinity to -4, -4 to 4. This might help some people, and 4 to infinity, increasing. So just going back, so to me, that problem is not rough. So number 1, I don't feel like that's going to be difficult for most people. Number 2 and number 3, that's pretty easy. 4 should be easy as long as you practice typing this in and make sure you know the steps to type it in the calculator. 5's not bad. 6 can be bad. You need to make sure you can solve that you know how to make the graph, you know how to do the test point. 7 is a matter of following these steps, making sure you know how to set up the problem and make sure you actually answer the question and not quit before you're done, I guess. 8's not bad. 9 gives people fits just because of all the math that's involved in plugging that stuff in. 10's easy, 11's pretty easy. So again, it's not the hardest of the hard questions, but you want to make sure you practice and study for it. Focus on those ones you don't know. Okay. I'll post this today and then we'll finish recording it on Thursday.